We'll now discuss a couple of the applications of where we would use queues. One application for queues is whenever we're dealing with a printer. So if we have some job and we submit it to a printer, those are going to be arranged in the order that they arrive. So these printing jobs will be placed in a queue. So think about how a business is set up. You probably have some shared printer among several people. Everyone is sending in all these print jobs, these print requests. So the printer actually places these in a queue where the order that they print these requests would be depending on when those requests arrive in the queue. Another example involves networks. A lot of the networks are set up where personal computers actually have their disks attached to a particular machine, which is called a file server. Now, users on different machines are given access to these files on a first come, first served basis. So this data structure that's used for organizing the files for people to access would be a queue in this particular case, because if someone wants to access a file, it's on a first come, first served basis. If someone has a hold of the file, then if anyone else wants to access it, they're going to have to wait until that first person is done with using that file. Another application, and one that you're probably familiar with, are making phone calls to companies. Usually if you're calling for technical support or calling some company, you're placed in a queue whenever all the operators are busy. Then you keep getting told that your call is important and please wait in this queue until the next available representative is available to take your call. But that is another application. Another one that you're probably not familiar with, is there's actually this whole branch of mathematics, which is what's called queuing theory. And the idea with this theory is it involves computing, particularly with probabilities, about how long users are expected to wait in line, how long the line actually gets, and other such questions that involve queues. And the answers to these questions depend on several factors, such as how frequently do the users arrive in the queue, how long does it take to process a user once they're in the queue, and so forth. So there's this whole area of math where you can study these things with queues. We'll conclude this lecture by looking at the complete code for implementing a queue using arrays. We'll now go ahead and implement our queue abstract data type using arrays. And as we mentioned before, in this particular case, it probably makes sense to use our own array implementation instead of using the myArrayList class. And that's just because we have to handle that wraparound part. So we're just going to go ahead and implement our queue abstract data type from scratch. So we need to create a class. So we'll do public class, and we'll call this myQueue. And we want to be able to have this queue have any type that we want. So we're going to include the generic any type at the beginning. We'll then need to create a couple of instance variables. We need one to indicate the maximum size of the array data structure. So we'll do private int, we'll call it max size. We need a variable to keep track of the current size of the array, so we can check to see if it does ever become the maximum size. So we'll do private int, and we'll call this current size. Okay. We need the array itself, so we'll do private, and then we can take advantage of any type, and we're going to have an array of that type, and we'll call it the array. Then we also need to keep track of the front and the back of the queue, so we need to have some variables for it. So private int front, and then private int back. Oops, there we go. Okay, so now we need a constructor, and we're not going to implement a default constructor. We're just going to have, the only thing we're going to pass in here is some integer that's going to indicate the maximum size of our queue. So we're not going to have a default constructor. We're just going to have the maximum size be a parameter. So we'll have max size be s. So then we'll create our array. So we need to create an object. So we'll do object because it is a generic, the most generic data type we have. Now we do need to do one more thing with this. We have to typecast this to the appropriate data type. Since this is an array of any type, we need to typecast it to it. I can't do new any type. That's going to give me a compile error. But I can do this. So do any type with square braces and typecast it to that. This will cause a compiler warning, but that's okay. That's perfectly fine if we get a compiler warning with this. We need also initialize our front. We'll set that to 0, and we're going to set our back to -1.
because remember when we on queue, we're going to increment back before we actually insert. And then we're going to set our current size to 0. Okay, that takes care of our constructor. So now we need to implement our onQueue and dequeue methods. So let's do onQueue first. So do public void onQueue, and this is going to be any type, and we'll just call it X. So the first thing we're going to do is handle that wraparound case. So this would happen if the back is pretty much at the end of the array. So we need to check to see if back is equal to max size minus 1. And just to be safe, I'm going to put this parentheses. I don't think that's necessary, but we're just going to play it safe. So if that's true, we're going to set back to be -1. And then afterwards, whether or not we do wrap the back variable around to the beginning of the array, we'll do the array. And here we're going to increment back and set it to X, and then increment our current size by 1. So notice that this is the reason why we're using back, initializing it to -1, because we're going to increment back before we actually use it. This is intentional. Okay, so that takes care of onQueue. So let's implement dequeue. So public any type dequeue, because we're going to have it return the value that is removed from the queue. So we need to create a variable of that type. We're going to call it temp, and we're going to say it is the array, and it's going to be whatever's in the front of the array, and then we'll increment afterwards. So the plus after front means we'll take what is currently at position front, and then we increment the value of front. Now after we do that, we need to check to see if we're at the end of the array. We need to wrap around. So we'll do if front equals max size, then our front needs to be 0. And regardless of whether we wrap around or not, we need to decrease the value of current size. So we'll do minus minus, and then we need to return the value of our temp. And then finally, we're going to implement the isEmpty method, just to make sure that if the queue, we need to do a check to make sure that the queue isn't empty. We'll do return current size equals 0. There are other methods we could include in here, like the size of the queue and a few other things, but this is the basic stuff. We gotta have at least the constructor, the onQueue, and the dequeue. We could implement a view the front of the queue. We could do like view the back of the queue. We could do all sorts of stuff, but this is enough for what we're trying to do. So let's go ahead and save this. We're gonna call it myQueue. All right, so we got our queue class. So now we need to construct a client. We're going to actually add a couple things to the queue. We're going to remove some stuff, print some things. So we'll create a new Java program. We'll do public class myQueue client. And we need our main methods, public static void main string args. So now we'll first create an object of our myQueue class. So we'll do myQueue, and we'll do integers again just to make it very simple. We can do doubles, strings, and so forth, but we'll do integers. And we'll call this myQueue equals new myQueue with integer. And here I'm just going to set the max size of my array to be 5 in this case. Well, it'll be a small queue. We're not going to put too many things in here. So we got our queue of size 5. So now let's add some elements to it. So we'll do myQueue onQueue 5. In hindsight, we probably would have wanted to include like a check in our onQueue method to make sure that the current size does not exceed the max size, but we won't worry about that right now. But if we were coming up with a better implementation, we would want to include that check. But let's add a couple more things. myQueue, if I could spell, no. There we go. I cannot type today. Do 10 queue onQueue 15 myQueue dot onQueue 20. Okay, so that adds 4 things to our queue, and then we'll just dequeue a couple things. So we'll do a while loop, and this is where we'll take advantage of the isEmpty method. So myQueue is empty, and then we'll just print out whatever we dequeue. So myQueue.dequeue plus and some quotes. And there we go. So we'll save this, my queue client. So let's go ahead and compile this to make sure there aren't any errors. We'll compile. We do get that one warning about the unchecked cast, as I mentioned before. That is from this line right, if I can get to it. This line right here is what's causing that warning. That's perfectly fine. There's no issue with that. We should be okay there. So what we're going to do is we're going to queue 5, 10, 15, 20. Then we're going to dequeue 5, 10, 15, 20 and print as we go. So if this works properly, it should print 5, 10, 15, 20. And there we go, 5, 10, 15, 20. So that does print. Like I said, if you want to make this a better implementation, we'd probably want to include a check in onQueue to make sure that the current size does not equal the max size. And we'd probably want to also do a check in dequeue to make sure that the current size is not already 0. So those would make those implementations a little bit better, but this does give us at least a feasible working implementation of our queue data structure.